Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Welcome back. Problem 4-2. The statement is copper shaft is subjected to axial loading as shown. So you can see this is a copper rod and axial loading is given. Determine the displacement of end A with respect to end D. So you have to find the displacement of point A with respect to point D. If the diameter of each segments, that is DAB 0.75 inch, DBC is 1 inch and DCD is 0.75 inch, and take elasticity of copper is 18 × 10⁻³ ksi. So we will start from given data. In given data it is given that E of copper is equal to 18 × 10⁻³ ksi. Clear. Diameter of rod AB, DAB is given as 0.75 inch. D of BC is equal to 1 inch. This is DAB, DBC. Clear. And D of CD is equal to 0.5 inch. So what we have to find is that displacement of point A with respect to point D. So I will write it, displacement of point A with respect to point D. We have to find this. Clear. So first we will find the displacement in each rod, rod AB, rod BC and rod CD, and then we will sum all this. So for that I have to first cut the rod AB over any point along the length of AB. So if I cut rod AB at any point, clear, so this is D, this is A and this is B at any point. Clear. So at the end of rod A, so we have a load that is given as 8 kips. Clear. And if I cut it at any length, in order to keep it in equilibrium, this load will be equal to PAB, and this is from simple calculation, this is again equal to 8 kips. Clear. Now we will cut the rod BC at this point. I will use another color. So this is having larger diameter and this is rod AB. Clear. At A point this load is 8 kips. This is point A, this is point B. So at point B there are two loads, that is 5 kips and 5 kips. So now you can add them. These two rods are on left side and this force is on right side. So this is 10 and this is 8. So we need 2 force in order to keep in equilibrium. So I will write here this PBC will be equal to 2 kips, because it will keep, if you apply a 2 kips at this point, so this will be in equilibrium, because you can see 8 plus 2 is 10 in right side, while this 5 plus 5 on left side, so it will keep it in equilibrium. So from here we can get PBC is equal to 2 kilonewton. Now I will cut the third portion of the rod, which is over here, this. So if I cut it and take it from the right side, so you will see that at this end this is 6 kips. Clear. So in order to keep it in equilibrium, PCD will be equal to again 6 kips. Now we will find the displacement of point A with respect to point C, and we know that displacement is equal to PL divided by AE, and if there are more than one segment, so we will write summation. So starting from the first rod, so you can see here the load is in compression, so I will write displacement of rod A with point A with respect to point D, not C. This is point D. Clear. So displacement in this rod, since this is in compression, so I will write P is -8, length of this rod is 80 inch, so 8 into 80 divided by area of this rod, diameter is given, so area will be equal to pi by 4 into 0.75 whole square multiply by E, and E is 18 into 10 to the power 3, 18 into 10 to the power 3, clear, plus displacement in rod or elongation in rod BC. Now load in BC is given as this 2, PBC is 2, clear, so 2 into length of this rod is 150, so 150 divided by area, so diameter is given, so pi by 4, the diameter of rod BC is 1, clear, into E, which is 18 to 10 to the power 3. Now we will also sum the elongation in rod CD. So load in CD is also a tensile load, so it will be equal to 6 into length of this rod is 100 inch divided by area, which is equal to pi by 4, diameter of CD is 0.5 inch, so 0.5 whole square, this is 0.5, into E, which is 18 into 10 to the power 3. So one is in compression. From this diagram you can see this is in compression while two are in tension, because so these two are positive and this value is negative. So if you sum them, so you will get displacement of point A with respect to point B is equal to 0.111 inch, clear. So this is a positive value, so we can say that the positive sign indicates that point A or end A moves away from end D. So this point is moving in this condition, in this load, this point A moves away from point D, and this displacement is equal to 0.111 inch of point A with respect to point D. I hope you have a clear understanding. Thank you for watching.